Hey everybody, so I'm so sorry that this came up late, but this is basically a review for what we've learned for your test. Now, a lot of you have been really good about coming up with different ways to solve problems, so I'm going to use the double number line method, but if you're getting the right answer and you're doing it a different way, that's fine. No one's going to mark off points if you don't use a double number line, but my recommendation is if you're a little unsure on how to do this or you're not getting a lot right, please try to use my method. So the first thing we did in class was we talked about how to use relationships to solve problems for other quantities. Meaning, for example, if you go to a store and you find out that 7 bananas cost $2.10 and you want to buy 15 bananas and you want to know how much that's going to cost, this is what we've been doing in class. Now, I don't know why someone would really want to buy 15 bananas, but let's just pretend. Okay. So what we talked about in class is the way you can do this is you really have to find out what we call the unit rate. What you want to know is you want to kind of find out how much is, forget about 7 bananas. It's more important to know what about 1 banana. Now, by the way, if you do go to a store, bananas are generally actually Trader Joe's. You can buy banana. Usually it's measured in weight. So some of you who have been to the grocery store might say, Mr. Katz, this is a silly example. You don't sell bananas by banana, but some stores do. So we're going to go ahead. Do not forget to write a label. The top's going to be for bananas. The dollar sign for money is going to be the bottom. You could have switched them if you wanted. And then we go ahead and we say that for 7 bananas, it cost $2.10. Now you could make that 2.1 because the zero in a decimal is not important there. And then we have to figure out, well, what about, forget 7 bananas, what if we buy 15? Right? So the way we talked about in class on how we did this is we brought the 7 bananas back to 1 banana because you're trying to go from 7 to 15, figuring out how to do that. And then you do that, remember, by dividing by itself. 7 divided by 7 is 1. And then once you get it to 1 banana, you know that if there's 15 of them, you're just going to multiply by 15. So basically, we're just going to do the same thing for the money. And if you do the same thing for the money, you're going to find out how much 15 bananas cost. So I have my handy dandy calculator. We said that this would be a unit that it's okay to use a calculator. It's about more understanding how to do the questions. So I'm going to do $2.10 divided by 7. And when I do that, 2.1 divided by 7, you get 0.3, 0.3. Now remember, that's actually, it's not 3 cents. 0.3 actually means 30 cents. So each banana costs 30 cents. Well, if I know what 1 banana costs, then all I have to do, there's 15 of them. I'm going to do exactly what I did on the top. I'm going to multiply by 15. So times 15, and you get 4.5. Now remember, 4.5 does not mean $4.05. It actually means $4.50. So that's the answer to my question. Now, let's have you try one, and I'm going to go ahead and let me pause the video real quick so I could write the new problem. All right, so there's runners that run to practice for a marathon, and we know that there is a certain someone that takes 15 minutes to run 2 miles. This would be a really good runner. That's a very fast pace. Maybe not a professional runner, but it's a very good pace. And we want to know how long would it take them to run a marathon? A marathon is 26.2 miles. Right? So again, we know that they run 15 miles to run 15 minutes to run 2 miles, and we want to know how many minutes. So we don't know how many minutes to run 26.2 miles. Now, folks, I'm going to let you pause the video and do it yourself. Give an answer, and then I'm going to show you if you got it right, great. If you got it wrong, I'm going to show you how you should have done it. Right? So right here, I'm gonna use the double number line method. Oh, that is not a good double number line, is it? Let me go ahead and erase. Eraser. There we go. All right, so I got my 2. Oh, I did it again. Well, that's really annoying. Sorry, folks. Let's try this one more time, and then I'm going to maybe not even make my double number lines. So, all right, that worked. So we know in this problem we're comparing number of minutes to number of miles. Now, it's okay if you would have totally switched those up. That's fine. But as long as you put the minutes on, you got to match the 15 with the minutes and the 2 miles with the 2 with the miles. And then here we're asking to run 26.2. So the 26.2 goes here. Okay? So now remember, all you're doing is you're bringing it, forget about 2 miles. Let's figure out how long it takes us to run 1 mile by dividing by 2. And then once you get a 1, you're just going to multiply by 26.2. So let's do the same thing on the top. 15 divided by 2 is 7.5. That means you run 1 mile in 7.5 minutes, 7.5. Then we take 7.5 and I'm going to do 7.5 times 26.2 because that's what we did on the bottom. 7.5 times 26.2 and you get, wow, that is a long amount of minutes. Well, actually, no, I guess it's not that crazy. So you would say that it takes that person 196.5, assuming they ran the same pace the whole time, which you might not be able to run the same exact pace the whole run, but that's how many minutes it would take you. Now, if you wanted to know how many hours that is, remember there's 60 minutes in an hour, so I'm going to divide by 60. You didn't really have to do this, but just so you know, this many minutes is about 3.28 hours, which, by the way, does not mean 3 hours and 28 minutes. We'll talk about that later. That's 3.28, so a fraction of an hour. So a little more than 3, but not even 3.5 hours. All right? So next, what we learned in class, let me go ahead and figure out a way to erase all this. I thought that works, but apparently it does not. Oh, all right, let me go ahead and pause it so that I can clear the screen. See, I figured out if I reload it should work. All right. So the other thing that we learned in class, which we are going to assess you on, is how you find percentages of a number. And hopefully you're laughing right now at me because you can see that did not actually work. Finally, I figured it out. You guys don't know how long that took, but that took a really long time, probably more time than it should have taken. So one thing that we did is we learned how to do percentages. So for instance, when you go to a restaurant and you have to tip 20%, you need to know how to find 20% of a number. Like maybe the bill was $35. You need to be able to find a percentage of a number. Okay. Now, if I told you that in our class, there were 60% of the class were girls, well, you would be finding 60% of another number. So basically being able to find a percentage is something that we use a lot. Okay. Now, one thing that we did talk about in class first was that finding 10% is actually pretty easy because all you're doing is dividing by 10. So let me walk you through a reminder on how to do that. If I asked you to find 10% of the number, and I'm just saying 40, okay, that means that the whole thing is 40, okay? So there's 40 in this big chunk, this total. And 10% would be a small part of it. So we're looking for like a piece of the pie, for example, okay? Now to do that, all you have to do is divide by 10. Now in class, we said that there's an imaginary decimal. It's not really an imaginary because it does exist, but if you don't see a decimal, it's actually at the end of every number. 40 is like 40.0. If you go to a store and something is $3, sometimes they'll just say 3, or sometimes they'll say 3.00. It's the same thing. So when you divide by 10 or take 10% of something, all you're really doing is moving the decimal once to the left. So 10% of 40 is 4.0, which means 4. Okay. And you could actually also do that with really big numbers like 200. Well, that's not really big, but if I said what's 10% of 200, I'm going to take 200 and I'm going to divide it by 10. So I move the decimal back once and you get 20. So knowing how to do that actually really helps us out because, let me just go down the page. The reason why it helps us out is because you could actually use that to figure out 30% or 40% or 50%, because for instance, 30% of something, let's say I wanted to know what is 30% of 100. Okay. Well, remember, I'm going to first find 10%. 10% of 100 means I just move the decimal. Remember, I just divide by 10. I'm going to move the decimal back 1. And if you move the decimal back 1 time, the imaginary decimal, you get an answer of 10. So 10% of 100 is 10. Well, guess what? 30% is just 3 of those. There's 3 10%. So if you take the 10, and because 10 times 3 is 30, if you multiply by 3, you get 30% would be $30. Now, how does that help you in real life? Well, if you go to a store and something is $100 and it says 30% off, Well, now you know 30% is $30. So you could take it off of the 100, meaning you subtract it. So now you know you're going to pay 100 minus 30. You're only going to pay $70. Really important when you go to stores to know exactly what are you going to pay with these sales. It's also important, let's say that we go to a restaurant and we want to, our bill, for example, is $25. And I want to tip the waiter or waitress 20%. Well, let's first find 10%. If you find 10%, remember we're just moving the decimal back one time. So the imaginary decimal, if you move it back one time, you get 2.5. That's $2.50. Well, that's 10%. Well, how many 10% are in 20%? Well, there's two of them. So I'm going to multiply by two. And that's how I know to this day when I go to a restaurant, I know that I'm going to have to tip the waiter or waitress $5 if it was a $25 bill. Okay. Now, let me give you guys some problems and see. And I'm going to give you three problems. And each one, if you get it wrong, you could still get the next one right. Okay. So you make sure you pay very close attention to each kind of question and when we go over it. Okay. All right, folks. The first question I want to ask you is what is 10% of, let's say 50? All right, go ahead and answer that. So hopefully, folks, 10% of 50 means you're just dividing by 10. So you're moving the imaginary decimal back once. So it's right there. So you go back one right there and you get 5. So your answer should have been 5. 5 is 10% of 50, which means if you have a big chunk that's 50 and you took a small piece of it, 10% of it, you would be taking 5 out of it. Next one. What is 20? Nah, you know what? I'm going to go even harder than this. 40% of 200. So again, remember, folks, that means that the big total is 200. And you're taking 40% of it. So like there's 1 10%, 2 10%, 3 10%, 4. So it's like this. You're going to take this much of the 200. Okay, not half of it. You're only going to take 40%. 50% is half. Okay. So go ahead and do that. Hopefully what you did is you took first 10% of it, which means if you take 10% of it, remember I moved the decimal back once. So I know that there's in 10%, there's 20. But I want to go all the way to 40%. So remember you do times 4 because there's 4 40% in 10%. And I'm going to multiply the 20 times 4 and I would find out that 40% of 200 is equal to 80 because 20 times 4 is 80. All right, last one. You guys please find out what is, well, 70%. 70% is almost all of it. Well, not really all of it, but it's a good amount. You're going to have a lot of it. What is 70% of the number 80? All right, go ahead and try that. Okay. Just in case, remember you first find 10% and you get 8. Because remember, move the decimal back 1. You divide by 10. Now, how many 10% are in 70%? Well, there's 7 of them. 10%, 10%, 10%, 10%, you'd eventually get to 70. So really we're multiplying by 7. And if you take 8 and multiply by 7, you would get 56. And 56 is your answer, which kind of makes sense because you're taking, 70% is not really, it's a good amount of the 80. And if you take 56 out of the 80, that's a good amount of, 56. 56 is close to 60. That's a good amount of the 80. And that's how we do those kind of problems.